Go ahead, try it right now. Trying to tickle yourself. Doesn't work, does it?
Now, if I had a friend here who could tickle me, I'd be squirming and laughing uncontrollably. So, what's going on? Why can your best friend reduce you to a giggling mess, but you can't do it to yourself? The answer is way more fascinating than you'd think, and it all happens in a walnut-sized part of your brain you'd probably never guess. First, let's understand what actually happens when you get tickled. There are actually two types of tickling. The first is called nismesis. That's the light, itchy sensation you get when something barely touches your skin, like a feather brushing your arm, or an ant crawling on your foot. The second type is gargalesis, and this is the one that makes you laugh. It's caused by deeper pressure on sensitive areas like your ribs, armpits, or the soles of your feet. This is the tickle attack kind of tickling. When someone tickles you, two main parts of your brain light up. The somatosensory cortex processes the physical touch itself, and the anterior cingulate cortex processes the pleasant, or sometimes not so pleasant, feeling of it. But here's what's weird. When researchers at University College London used brain imaging to watch what happens when people tickle themselves, those same brain areas barely respond at all. The sensation just doesn't register the same way. So why? The answer lies in a small structure at the back of your brain called the cerebellum. You might think the cerebellum just controls movement and balance, and it does. But it also does something incredibly sophisticated. It predicts what your body is about to do and what sensations that will create. Here's how neuroscientist Sarah Jane Blakemore explains it. The cerebellum can predict sensations when your own movement causes them, but not when someone else does. So when you reach your hand toward your own ribs, your cerebellum goes, okay, hand moving toward ribs in 3, 2, 1. Touch incoming. It knows exactly when, where, and how strong that touch is going to be. And here's the brilliant part. When your brain can predict a sensation that precisely, it actually cancels it out. It dials down the response in your somatosensory cortex. The touch still happens, but it doesn't feel tickly anymore. Scientists call this sensory attenuation. Your brain essentially mutes sensations it created itself. But when someone else tickles you, your cerebellum has no idea what's coming. It can't predict the timing, the location, or the intensity. So your somatosensory cortex responds at full strength, and suddenly you're laughing uncontrollably. Now you might be thinking, okay, but why would my brain cancel out my own touch? Think about it this way. Right now, your clothes are touching your skin. Your arms are probably brushing against your sides. If you're wearing socks, they're touching your feet. If your brain processed all of that touch information at full intensity, you'd be constantly distracted by your own body. It would be impossible to focus on anything else. So your brain has evolved to filter out predictable, self-generated sensations. That way, it can dedicate its processing power to new information, like someone unexpectedly tapping you on the shoulder, or that spider crawling up your leg. In fact, some scientists think tickling might have evolved as a defense mechanism, a way to alert you to small creatures crawling on sensitive areas of your body. That would explain why the most ticklish spots are often vulnerable areas like your neck, armpits, and feet. And if your brain is going to use ticklishness as an alarm system, it better not go off every time you touch yourself. Otherwise, it's a pretty useless alarm. But here's where it gets really interesting. Those same scientists at University College London built a machine to test whether they could trick the brain into letting you tickle yourself. Here's how it worked. You close your eyes and pull a lever. That lever controls a robot arm with a piece of soft foam on the end. When you pull the lever, the robot tickles your hand. Now, if there's no delay, if the robot tickles you instantly when you pull the lever, you don't feel very ticklish. Your brain still predicts it. But here's the cool part. They introduced tiny delays, just a fifth of a second or half a second between when you pulled the lever and when the robot touched you. And suddenly, it worked. People reported feeling genuinely tickled by themselves. The longer the delay, the more ticklish it felt. Because with that delay, your cerebellum couldn't accurately predict the sensation anymore. The prediction didn't match reality, so your brain stopped canceling it out. All it took was introducing a tiny bit of unpredictability. This isn't just about tickling, by the way. It's why you can't hear your own voice the same way others hear it. It's why you don't notice the feeling of your tongue in your mouth until I just mentioned it. Sorry about that. And fascinatingly, this system can break down in certain conditions. Studies have shown that people with schizophrenia who experience auditory hallucinations sometimes can tickle themselves more easily than others. Their cerebellum isn't properly distinguishing between self-generated and external sensations. So something as silly as tickling actually reveals something profound about how your brain creates your sense of self by constantly monitoring what you're doing versus what the world is doing to you. So next time someone tickles you, remember, it only works because your brain lets it work. Your cerebellum is choosing not to cancel that sensation out because it genuinely can't predict what's coming. And that's actually pretty amazing. Your brain has a built-in system that filters out the predictable while keeping you alert to the unexpected. You just can't use it to give yourself the giggles. Trust me, I've tried.